Hey everyone, it's Mr. Salmingo. Sorry I couldn't be there today. I was scheduled for a meeting at my grad school after lunch, and it's actually for today and yesterday, but since they switched from block schedule to regular schedule, now it conflicts, so I won't be there again today. I'll be back tomorrow. But I want to go over some of the questions from yesterday because I saw some misunderstandings, so I want to make sure that you all understand what we're doing. So first of all, 1, 3, and 5, these ones most of you got correct. You understand it. So if I look at number 1, just to give you an example, I have a function negative x plus 1. I want the area underneath it, which is in blue, and I'm going to rotate it around the x-axis. And again, I asked you to take a screenshot of this and put it in your explain everything. Now what you do is you basically take a sliver of the triangle and you're going to rotate that around, and it looks like a disk. There's no hole. See, it's connected to the x-axis, and that disk, remember the area of that disk is going to be pi r squared times a delta x. So let me write that down. This one, again, I'm going, since my rectangles are going from left to right, it's going to be from 0 to 1, pi r squared delta x, because my rectangles are going this way, left to right, delta x. My r, you may notice the radius just of this yellow rectangle, if it was rotated around the x-axis, the radius is going to be equal to the height of the function, which in this case is negative x plus 1. So I will write that in, or substitute it into my antiderivative. Like so. And then what you can do is I could factor out that pi. And then I could also, to make this easier myself, I could FOIL this, but what I'm going to do is I'm just going to leave it as it is. So yesterday in the homework, I just asked you, or in the classwork, I just asked you to leave it like this. But what I want to teach you today is how do you do this like through a calculator? How can I make this process easier? So there's this website I want you to go to. It's called wolframalpha.com. So if I go over here, let me clear this last one. wolframalpha.com. When you go to the website, it'll say, hey, download this app, but the app's $3. It's not worth it. It's not worth the $3, so you could just go to the website and do the exact same thing. This website, what makes it so powerful is I could type in straight English, and it'll translate it into math and calculate it for me. So this is one I did previously. It's kind of similar to the problem. Let me show you how to do it in Wolfram Alpha. So if you remember from the previous problem, I want the antiderivative, or the integral, of 0 to 1 of negative x plus 1 squared with a pi on the outside. So what I'm going to do is I'm going to do just integral and then basically add pi at the end of it. So I want the integral of parentheses negative x plus 1 close parentheses squared. So integral of negative x plus 1 squared, which is what we talked about, right? Integral of negative x plus 1 squared, and I want it from 0 to 1. So I'm going to just write literally from 0 to 1. And then I'll calculate it. I'll press go. And it gives me the answer. This is exactly what it looked like. From English, it made the math. It gave me the answer, 1/3. And then this is like a different integral. Remember, we're doing a rotation, so this isn't exactly what the picture looks like. And it says the answer is 1/3. So if I go back to my problem, this is actually just 1/3. And I saw that pi on the outside. So my answer is going to be pi over 3. So literally, you can go into each of these problems. Remember yesterday I told you to stop here and put it into Wolfram Alpha, and it'll give you the answer. You don't have to do, you know, this one. You might have to do FOIL, and then antiderivative, then plug in 1, plug in 0. We're past that point now. So 1, 3, and 5, almost exactly the same. Number 5 is a little bit different, so I want to go over number 5. You may notice that in number 5, actually let me move down here. You may notice in number 5 is that there's actually a hole now going to be in the bottom. It's not just going to be a disk anymore. This is going to be a ring or a donut. Okay, if I rotate this tiny, tiny, tiny little yellow rectangle around the x-axis, I will get a disk, or a ring, or a donut. So I'm going to do the antiderivative. In this case, you can see it's from 0 to 1. And if you remember, it's pi r squared minus pi r squared. You notice my rectangles are going from left to right. See my rectangle, it's up and down going from left to right. So delta x. The r's, if you remember, this one's going to be r out minus r in. So the outside circle subtracted by the inside circle. In this case, you may notice that, let me zoom in for you guys. You may or may not notice that this one right here is actually x squared, this one on the top, and this one on the bottom is x to the third. So if I rotated this rectangle like this to make a donut, this top one, or radius out, would be x squared, and the radius in would be x to the third. So what I'll do is I'll go back to my problem, and I'll make r, first of all, you may notice I have a pi here and a pi here, so I'll factor out the pi. The r radius out is going to be x squared. And the one on the inside is going to be x to the third. Like so. You may notice that I could simplify this so much easier by multiplying these exponents. So this becomes x to the fourth, and this becomes x to the sixth. I can't reduce that, I can't add these together, they just have to stay as they are. So now again, I finished off my integral, I finished up like how this is supposed to look like. So what I'm going to do now is I'm going to put this into Wolfram Alpha and figure out the answer. This is x to the fourth minus x to the sixth from 0 to 1. So I'll go into Wolfram Alpha. I'll literally type in integral of x to the fourth minus x to the sixth from 0 to 1. Integral of x to the fourth minus x to the sixth from 0 to 1. I'll hit go. And it tells me my answer is 2 over 35, or approximately 0.057142. Okay. And if you really, what's really cool about this too, it also does indefinite integrals as well. So if you don't, if you don't have bounds, it also tells you what the antiderivative is, just to check your work. So this one's 2 over 35. So if I go back to my problem, it's pi 2 over 35, or 2 pi over 35. So Wolfram Alpha really makes your job a lot easier. Okay. Now, here's where the problem, and I'm doing this for you because I want you to do this for all the problems from yesterday. And some of you didn't submit it or weren't here, so I want you to go through these one more time. The question that I have is number 7 and 9. That's where a lot of you got confused. So let me erase this part right here and do 7 for you guys, and I want you guys to redo 7 and 9. Okay? So this is what it looks like. Now, in this problem, if I rotate this yellow rectangle, see how they made it for me? It's going to go around the y-axis. So the question says to go around the y-axis. I still get a disk. Okay? You may notice though that this is not the rectangle. These rectangles went from, they're vertical and they go from left to right. These rectangles are going from the bottom to top now. So it changes everything. It's not just what we've been doing. So that's why I want you guys to read the example. So in this case, if my rectangle is different, this would go from 0 to 2. But the problem is that this rectangle is actually sideways and going from bottom to top. So instead of saying 0 to 2, what I should be saying is from 0 to 4. Okay. It's still going to be a disk when I rotate it around the x. It's still pi r squared. And in this case, since I'm going top to bottom, since my rectangle is sideways, this should actually be delta y. Okay. These don't match. Okay. Normally, previously, what I would do, you may notice in this problem it says x squared. Okay. So previously, what I would do is I'd put x squared here. But you may notice something. If I put x squared here, the variables still don't match. So the question is, what do I do? Basically, I need this to be y. So look at this function. It says y equals x squared. Since I want to replace it with a y, what I'm going to do is I'm going to get this x by itself. Okay. So what I'm going to do is I'm going to square root both sides. The square root of y equals x. So basically what I'm saying is that the radius of this rectangle, or the radius of this piece, is equal to x, the width, and the width is delta y. Or in other words, I'm just converting my function between x and y, or I'm just going to x by itself instead of y by itself. So actually, I'm going to take the square root of y and put this here. Okay? So my new question will be antiderivative 0 to 4. I'll move the pi to the outside, and then I'm going to get the square root of y squared, delta y. And you may know the square root of y squared is just y. So what I'm going to do is I'm going to go out to Wolfram Alpha. Again, it's pi 0 to 4 of y delta y. So I'll go into Wolfram Alpha and I'll figure this out. Here it is. Antiderivative integral of y from 0 to 4. So it looks exactly like I wrote it. Remember, it's 0 to 4 of y. So 0 to 4 of y dy, or delta y, equals 8. If I go back to the problem, you see I have a pi here, so my answer is going to be 8 pi. So I think that you all understand how to do this. Hopefully it's makes more sense to you. I'm going to give you guys a quiz tomorrow to make sure that you understand this topic, so please make sure that you watch this video, make sure you go over the example questions. I'm going to post the solutions later on today, and also I need you to redo the odds, right? If you have it on Split Everything, you could just fill in the Wolfram Alpha stuff, and then I want you to do the evens now too. I want you to get a firm understanding about how to do these volumes. And I'll see you all on Friday. Take care.